So say I was asked to graph this. F of t equals 2 times the sine of 3t minus 5 pi minus 3. So I know I'm starting with a sine function, so it's going to mimic a sine function. It's going to start on the baseline, move up to a highest point, return to the baseline, move down to its lowest point, and return to the baseline again. That's what a sine function typically does. So knowing how a sine function typically reacts and moves is going to help us with this as well. But I do have to find the other aspects of the graph. So namely, since that 2 is in front there, I know the amplitude is going to be 2. I also know there's no reversal because there's no negative sign over there. So the graph will continue to start at the baseline, move up, move down to the baseline, move down to its lowest point, return to the baseline for a full period. Now what is that period going to be now? Well, that period is going to be 2 pi divided by that 3 because that's what b is. So instead of me going a full 2 pi units before it does a full repeat or does a full motion of that sine pattern, I'm only going to move 2 pi over 3 units this time. As far as the phase shift goes, the phase shift kind of gives us a new place for it's going to take the place essentially of our y-axis. So this tells me that my phase shift is going to be 5 pi over 3, so generally I'm going to kind of move my quote-unquote y-axis 5 pi over 3 units to determine a new starting point. And as far as the vertical shift or baseline goes, that's going to be at y equals negative 3. So when I start a graph for this, I mean, having this information ahead of time lets me know how to kind of scale my graph a little bit. Like for instance here, I see the period and the phase shift are both written in terms of pi over 3s. So it would be a good idea for me to scale my graph going by pi over 3s to make my life a little easier for drawing purposes. I notice that typically my baseline and vertical information is always going to be in whole units, so I can just go with regular numbers for my y coordinates. So I set up a little graph like this. Now how far you go with it is going to depend on how much you want to draw. Sometimes when I ask you to draw a graph, I'll provide the graph for you. Just keep in mind that the graph, as far as highest points and lowest points go, should fit on the graphing region. And you'll often be asked to produce at least one period of the graph. You don't have to keep the graph going on forever and ever, although I wouldn't mind seeing that. But you do have to make sure that you are putting things in the right place and showing one full period, everything being correctly where it needs to be. So when I started the graphing process, I start with the phase shift and the baseline to kind of create my new axes. So I can see my phase shift takes me over here to, so you get a pointer going on there. Takes me over here to where 5 pi over 3 is. And I take my baseline down here to negative 3. And I know a sine graph starts on its baseline. So it's going to start where these guys are intersecting each other. Now I know that instead of moving 2 pi units before I do a full up, down, back up again motion, that I'm only going to move 2 pi over 3 units. Now notice the way I have the graph scaled. I have every 3 lines, as I move from left to right, be giving me pi units. So that means I'm moving by pi over 3. So 2 pi over 3, starting here, would go 1 pi over 3, 2 pi over 3. So that's where I would be for my for where the graph's going to end its first full cycle. So I also know that exactly halfway between the start and end of a full cycle, the graph also passes through the baseline as well. So I know that in one full cycle, it's going to pass through the baseline at these 3 specific points. I also know a sine graph between the beginning of it and the next time it goes through the baseline is when it reaches its highest point. So somewhere up here is going to be its highest point, like somewhere along this area here. And I know it's going to be 2 units up, so it's going to probably be around here. And exactly halfway between this second time it meets the baseline and the last time it meets the baseline for that first cycle is going to reach its lowest point, or in this case be 2 units down from the baseline. So that's how I get these 2 points. That's just me knowing how a sine graph typically behaves. And so one complete cycle or one full period would look like this. And if I continued this on forever and ever, that's what the graph would look like. So just gathering these 4 pieces of information gives me a lot of information to create a really accurate graph without having to do a whole lot of plotting, like putting a value in for t, getting a number, and doing that stuff. I get everything I need, and it's an accurate graph based off of that.